Hello everyone. Today we are going to start lecture 04 of class 8 mathematics chapter number 9, which is algebraic expressions and identities. Now in this lecture we are going to continue our discussion on multiplication of two algebraic expressions, where we are going to talk about multiplication of a monomial and a binomial. Now monomial is a single term algebraic expression and a binomial is a two term algebraic expressions, and we are going to use the distributive property of multiplication over addition to solve them. So if I have to write in a symbolic form, I can say that if P, Q and R are three monomials, okay, these are three monomials, then we are representing them by symbols, okay, monomials. Then we have first, what we can do is, if you multiply like this, if you are multiplying this monomial P with the sum of Q and R, now obviously if you add Q and R in if these are unlike terms, it will be a binomial, right? So that is what I am talking about. We are multiplying a monomial to a binomial, and using the distributivity of multiplication over addition, we will write P into Q plus P into R, and that is what we are going to do in the actual questions also. Similarly, if you use commutative property, then it would be like this. If you multiply Q plus R into P, that is, you multiply a binomial to a monomial, then also we will use the distributive property. So first of all, Q will be multiplied by P and the final result would be added to R multiplied by P. Okay, so you can very well see that these are nothing but the distributive properties we have already studied. Okay, so if you write, if you want to write in words, so we can say we multiply each term, of the binomial Q plus R to the monomial, or you can say by the monomial, each term of the binomial Q plus R by the monomial P, and add the products to get the required result. Okay, so we can multiply each term of the binomial Q plus R by the monomial P and add the products to get the required results. Also, you can do that for subtraction also. Okay, here actually we are adding the two monomials. Okay, if they are unlike, the subtraction will also be monomial or binomial, so it is not an issue, but we can write like this also. Okay, let me again recall that if Q and R are like terms, then Q plus R will not be a monomial or will not be a binomial. Okay, Q plus R will be a monomial because like terms can be added and they can be subtracted as well. So you should remember that whenever you are talking about PQR, they should be unlike. Okay, that is when this formula will be applicable. So if you have P into Q minus R, it would be P into Q and just subtract P into R. Okay, nothing new. Similarly here, Q minus R into P, it would be nothing, Q into P minus R into P. Okay, so you can actually see what we are doing is we are using the distributive property, but you should be aware that whenever you are using this property, proper choice of signs must be needed. Minus is actually outside this product. Okay, so it will be negative for the entire product, not for individual one. Okay, similarly it may be possible that there are 3 terms, 4 terms. We are studying monomial by a binomial, but you can say we can multiply monomial to a trinomial also. In that case there would be third term also. The same formula would be applicable. You will multiply this P to the third term also, and depending on the sign you will add or subtract this particular thing. Okay, the term PQR can have their signs as well, so they will be changed. Suppose if R is a minus 2x square, then this minus minus would become plus. Okay, so you should be aware of the signs. This is the sign in the identity. Okay, the terms can have their own sign. It will be clear when I solve some questions. So let us just move on to the questions to understand how do we apply this method and how to take care of the signs, right? Okay. So the first question is multiply 2x by 3x plus 5y. Okay, so let us see this question. Now 2x has to be multiplied by 3x plus 5y. Okay, so it would be 2x into 3x. See, this is p, this is q and r, so p into q, okay, plus q and p into r, p into q plus p into r, so it will be 2x into 5y, right? So 2 into 3, now we know monomial, we know multiplication of monomial. See, so that is what we are doing. We are actually using these questions and breaking them into the form which we already know. We have already studied multiplication of monomials, so we are using that. So multiply the coefficients. So 2 into 3 would be 6, x into x would be x square. Similarly, 2x into 5y, so 2 into 5 would be 10 and x into y would be xy. Okay, so that will be the final product. So see, we have multiplied a monomial by a binomial within just a minute. Okay, so it is that easy. Let us move on to the next question. Now it says multiply 7xy plus 5y by 3xy. Okay, so same way, now we have to calculate 7xy plus 5y into 3xy, right? So what we can do is we have to multiply them individually. So 3xy would be multiplied by 7xy plus 5y. So this is q plus r into p. So p into q. So it would be like 7xy into 3xy plus 5y into 3xy. So see, we have distributed. So multiplication is distributed over addition. So you can see it would be 7 into 3, that is 21. Now xy and xy same. So x and x, their powers would be added. So it would be x square, and y powers would be added. So y square. Okay. These are from laws of exponents only. Now 5 into 3 would be 15. So x. Now y into y would be y square. Okay, if you want, then I should write that what identity am I using here. It is a raised to the power m into a raised to the power n equals to a raised to the power m plus n. That is what we have used here. X into x, so x to the power 1, x to the power 1, they would be added. Okay, so that is what we are doing here. So it would be 21 x square y square plus 15 xy square. Let us move on to the next question. These are easy questions, right? Now this question says that minus 3ab square upon 5 has to be multiplied by 2a by 3 minus b. Obviously these are unlike terms, so yes, it is a monomial into binomial. Okay. So minus 3ab square whole upon 5 into 2a upon 3 minus b. Okay, what it will be? It will be minus 3ab square upon 5 into 2a upon 3, right, minus. See, this minus is because of the difference between the terms. That is what I was talking about. So we have to take care of the sign. Okay, so you can clearly see that whenever we are multiplying, this minus is because of the formula. Okay, so minus 3b square is getting multiplied to 2a by 3 minus this minus the multiplied to b. Okay, now do not take minus b over here. You've already considered the minus here. Right, we have actually taken the difference of the terms, right? So what is the formula? Let me write the formula so it will become easy. I am using p cross q minus r is equals to p cross q minus p cross r. So this minus this q minus r is this 2a minus 2a by 3 minus b. So b would be considered without this negative sign. Okay, so that is what we are doing. So you have to take care of the signs as well. So 3 would be cancelled by 3 and minus, so 2 upon 5 would be the coefficient. Okay, and a into a would be a square and this would be b square, right? So minus 2 upon 5 a square b square. Now this minus, and okay, first of all let us see this. This is minus 3 upon 5 only, and a and b square into b would be b cube. Okay, So finally you can write minus 2 upon 5 a square b square, minus into minus would become plus, so it would be 3 upon 5 ab cube. Okay, so you can clearly see this is the answer. Okay, let us move on to the next question. Now this question says that find the product of 7 upon 2 s square t. Obviously s and t are variables, and s plus t. Okay, it is a monomial, it is a binomial, and verify the result for s equals to 1 by 2 and t equals to 5. So first of all, let us find what the product is, and then we will verify it. Okay, so 7 upon 2 s square t into s plus t. So it will be 7 upon 2 s square t into s plus 7 upon 2 s square t into t, right? So you can see that we have distributed this. So 7 upon 2 would be here only. Now s square into s would be s cube, and this would be t, plus 7 upon 2 would be here, it would be s square t square. So that is the result. Okay, so we can write like this also. So 7 upon 2 s square t into s plus t. So this is the result. So this is the result which we have to verify. Okay, so let us take the LHS. Now LHS equals to 7 upon 2 s square t into s plus t. Okay, and what is the RHS over here? RHS equals to 7 upon 2 s cube of t plus 7 upon 2 s square t square, right? So let us verify them for s equals to half and t equals to 5. So add s equals to half and t equals to 5. Let us see what LHS is. At this LHS was 7 by 2 s square t into s plus t, right? So it would be 7 by 2 into s square means 1 upon 2 square, t means 5, into s plus t, that is half plus 5. Okay, so that is what we have to calculate. So it would be 7 by 2 into 1 by 4 into 5, and it would be 1 plus 10 upon 2, right? So if we take LCM, it would be like this, which is nothing but 7 upon 8, right, into 5 into 11 upon 2, and if you multiply the numerators, you will get 385. 8 into 2 would be 16. Okay, nothing is common, so we cannot cancel out anything. So this is LHS. Let us talk about RHS at the same values. So RHS was 7 upon 2 s cube t plus 7 upon 2 s square t square. So it would be 7 upon 2 s cube means 1 by 2 cube, and t would be 5, plus it would be 7 upon 2 s square would be 1 by 2 square into 5 square. Okay, so it would be 7 by 2, 1 by 2 cube would be 1 by 8 into 5, plus it would be 7 by 2 into 1 upon 4 into 5 into 5, that is 25. Okay, so you can clearly see how we have to deal. So it is 7 into 5, that is 35 whole upon 16, right? And this would be 25 into 7, that is 175 whole upon 8. If you take the LCM, it would be 35 only. This would be 2 into 175, that is 350, which is actually 385 whole upon 16. So clearly LHS equals to RHS, hence verified. So the product which we have calculated was absolutely correct. Okay, We have verified them for these values, but you can clearly see that if we have applied the method right, they will be LHS would be equal to RHS for every value of identity, right? So let us move on to the next question. Now this question says determine each of the following products and find the value of each for x equals to 2, y equals to 1.15 and z equals to 1. So let us try the first one. Now 27x square into 1 minus 3x would be 27x square minus 27 into 3, we can directly multiply now, so it would be 87x cube, right? So 27 to 81, not 87, it would be 81. That is 29 into 3 is 87. Okay, so it would be 81x cube, right? Now we have to verify the result for x equals to 2, y equals to 1.5 and z equals to 0.01, but actually we do not have y or z, so we just have to put x equals to 1. Now for x equals to 2, LHS is equals to 27 2 square into 1 minus 3 into 2. So it would be 27 into 4 into 1 minus 6, right? So 27 into 4 would be 108 into minus 5. It would be minus 540, right? Similarly, what is RHS? RHS equals to 27x square, that is 2 square minus 81 into 2 cube. So 27 into 4 minus 81 into 8. Okay, let me do the calculation easily. So let me take 4 into 27 common. Okay, so this will come out, so there will be 1, and from 8 if 4 has taken common, so it would be 2, and from 81 if 27 has been common, so it would be 3. Okay, so you can do like that. See, you have just transformed the question into this way. Okay, so you can do like that, or that was the first way, or you can continue with the actual calculations also, right? So 27 into 4 would be 108, and what is 81 minus x cube? So you can calculate it. So 81 into 8, let us find 81 into 8. So it would be 648, right? So if you subtract 108 from 648, you will get minus 540. So you can clearly see LHS equals to RHS. So we have verified the result. Hence, so you can verify the result very well. Okay, let us move on to the next question. And actually, see, we have verified it. Let me tell you one more thing. The question asks for the value only. Okay, so the verification you have done will also provide the value here. We have done two things with one question only. See, what is the value? You just have to put x equals to 2 and find the value. So that is what you can calculate it either from the either side, either from the LHS or RHS. When you are verifying the question, you have calculated LHS to be minus 540, and since it is true, we have done it correct, so RHS would be same. Okay, so we have done the verification, but at the step of LHS only you got the value. So for x equals to 2, the value of this polynomial is minus 540. You can write like that also. Okay, so value of 27x square into 1 minus 3x at x equals to 2 is minus 540. Okay, so now you must have understood the concept of verification. Actually in this question, if you do not verify, that is okay, but you have to find the value. Okay, so let us move on to the second part. Let us try to solve it. Okay, in that second part, we will not do this verification part. Okay, we will directly calculate the value. You can either use the LHS or RHS, whatever you find easy. Okay, so the second part is 2z minus 3x into minus 4y. So let us try to solve it. So first of all, you have to carry out the product. Then we have to find the value. And this contains x, y, z, all three. Okay. Into minus 4y. So it would be like 2z into minus 4y. Okay. 2z minus 4y minus. It would be 3x into minus 4y. Okay, so 2z into minus 4y or minus 3x into minus 4y. So it would be minus 8 yz it would be minus 12xy, so it will be minus 12xy. If you open it, it would be minus 8yz plus 12xy, right? So now what we have to do, we actually have to find the value. Okay, so at x equals to 2, y is equals to 1.15 and z is equals to 0.01 comma this product, that is 2z minus 3x into minus 4y. You can put value in the LHS RHS, but I find LHS to be a bit easier, so let us calculate it that way. So 2 into z, so 2 into z is 0.01 minus 3 into x 2, that is minus 4 into y. What is y? 1.15. Okay, then it would be 0.02, right, minus 6 into, it would be 2.3 into 4, that is 4.6. So minus 2 into 1.15 would be 2.3, 2.3 into 2 would be 4.6. Okay, so after calculating this, it would be you can directly see 6.00 minus 5.98. So minus 5.98 into minus 4.6. So minus minus would be plus, so answer would be positive. So you just have to calculate 598 into 46. So let us find it. So it could be 6 into 8, 6 into 9, 6 into 5, 30, so it would be 35. Then 8 into 4 would be 32. 9 into 4, 36, and plus 3, 9. So 5 into 4, 20 and 3, 23. So it would be 8 and 0, so 1. So 10 and 5, 15. 5 carrying 1, 7. So it would be 27508. Okay. And we have to place the decimal from here only. Okay. So it would be 27.508. So you can clearly see that is the value of this particular expression at x equals to 2, y equals to 1.5 and z equals to 0.01. Okay, in this way you can calculate the value. So let us move on to the next question. Now this says simplify the expression and evaluate it as directed. So first of all simplify, and then we have to find the value at y is equals to 2. Very easy. Now 3y into 2y minus 7, 3y minus 4 minus 63. So it would be 3y into 2y, that is 6 y square. Now you should be able to directly multiply. So 3 into 2, 6, y into y square. Now 3 would y would be multiplied by 7. 7 into 3 would be 21. So it would be 21y, right? Minus 3 into y would be 3y. Then minus and minus it would be plus. So 3 into 4 would be 12 and minus 63 is already there. So it would be 6y square. Now 21 by 3y are like terms, so they would be added. So minus 21 minus 23, it would be minus 24 and y would be there only. 12 minus 63 would be minus 51. So that is the final expression. Now we have to calculate it at y equals to 2. So at y is equals to 2, not 2 minus 2, but y is equals to minus 2. Okay, at y equals to minus 2, 6y square minus 24y minus 51 is equals to 6 into minus 2 square minus 24 into minus 2 minus 51. Okay, it would be 2 minus 2 square would be 4. So 6 into 4 would be 24. 24 into 2 would be 48. So it would be 48 and minus 51. So 48 minus 51 would be minus 3 and 24 minus 3 would be 21. Okay, so that is the final answer. Very easy. Let us move on to the next question. Now it says subtract 3pq into p minus q from this. So first of all let us calculate the product and then we have to write. So after calculating the product we have to subtract it. Okay, so we should try to form that complete product actually which we have to subtract. Okay, see, we will calculate it individually, but it is better to write it like we have to find 2pq into p plus q. Obviously we have to multiply them and find this, but after finding the product we have to subtract this from this. So we have to subtract this 3pq into p minus q from this product. So let us write like that and let us solve them simultaneously. Okay, so 2 into pq would be 2pq into p, right, plus 2pq into q, minus it would be 3pq into p minus 3pq into q. Okay, so it would be 2p square q plus 2pq square minus it would be 3p square q minus 3pq square. Okay, so it will be 2p square plus 2p square q plus 2pq square minus it would be 3p square q plus 3pq square. Now 2p square q minus 3p square would be minus p square q, and 2pq square plus 3pq square would be 5pq square. Okay, so it would be the final answer. So you can clearly see it is very easy to calculate them, right? Let us move on to the next question. Now these questions should actually help you to avoid this second step. Okay, it is making it long and you should now be able to multiply them directly. Okay, so this says add p into p minus q, q into q minus r, and r into r minus p. Okay, so we have to add this to this and then finally r into r minus p. So p into p would be p square, it would be minus pq, plus q into q would be q square, it would be minus qr, plus r into r would be r square, it would be minus rp. Okay, so if you want to arrange them, you can arrange them also, right? So it would be p square plus q square plus r square minus pq minus qr minus rp. Okay, so you can directly calculate them. So that was the addition of these products. Let us move on to the next question. It says that add them. Okay, so now see what we have is we have monomial into trinomial. Okay, it is not monomial into binomial, it is monomial into trinomial. So the same formula, distributive property only. So 2x into x, not x, it was z. So 2x into z minus x minus y plus 2y into z minus y minus x. Okay, so that we have to do. Now clearly it would be what? 2xz, it would be minus of 2x square minus of 2xy. Okay, then it would be plus 2yz minus 2y square minus 2xy. Okay, so if you actually calculate them, see like terms are minus 2x square does not have any like terms, so write it like this. Similarly minus 2y square would be allowed. Now 2xz, and we do not have xz, so plus 2xz would also be like this. Now 2yz also do not have any like term, but 2xy and 2xy, so minus 2xy, they can be added since they are like terms, so they would be minus 4xy, and this would be the final answer. So you can clearly see that we can calculate the questions very easily using this technique of monomial into binomial or trinomial. Okay, so we have to just multiply them element wise. Let us move on to the next question. This says subtract 3k into k minus 4n plus 5n. So they've changed the variables from this particular thing, so we can do that also. So first I write it in this form. From this, so first of all we have to calculate 4 into k into 10n minus 4 into k, it would be 10n minus 3m plus 2k minus 3k into k minus 4m plus 5n. Okay, so it would be what? 4k will multiply them, so it would be 40 of kn minus, it would be 4 into 3, 12 of mk, it will be 8 of k square, 4 into 2 would be 8, k into k would be k square minus. Now see, 3 into k would be 3 k square. Now minus and minus, it would be plus. So 3 into 4 would be 12 and 12 mk. And finally minus into plus would be minus. It would be 3. Now 3 into 5 would be 15. Okay, so it would be 15 nk. 5n and k would be nk. So for see k square, it is 8k square minus 3k square. So it would be 5k square. You can easily calculate them. It would be 5k square. Now minus 12 mk and plus 12 mk will be cancelled out. And 40kn minus 15 nk, it would be 25 plus 25 nk. Right. So 5k square plus 25 nk. So it would be same. Okay. So you can easily calculate them using the concept of like and unlike terms. Let us move on to the next question. See, these number of questions now will make you able to apply this method without actually multiplying the coefficients and then multiplying the variables. Okay, you can directly do that. It will save you a lot of time. So subtract this from this. So okay, so let us write how to do it. So the question is saying from 4c to minus a plus b plus c. You have to subtract something. What you have to subtract? This 3a into a plus b plus c minus 2b into a minus b plus c. First of all, calculate it. You have to calculate them. Okay. Then you have to subtract. So since this is one complete particular thing, one particular expression, so I have kept it in a big bracket, and you can do that. Always try to use brackets. They will save you a lot of time. They will save you a lot of trouble. You will not commit any mistake. So it would be multiplying them. It would be minus of 4 minus. So it will come outside 4 into AC. Now plus 4b into c. Plus, if you multiply it, it will be 4. C into c would be c square minus. Now 3 into a would be 3a square because all are positive. So it would be 3ab and finally it would be 3ac. Now minus into, it would be 2ab minus 2b and it is minus b only. So it would be minus into minus, that is plus 2b square and it would be minus 2bc. Okay, so it is 3a square plus 3ab plus 3ac minus 2ab plus 2b square minus 2bc. Okay, so it would be minus of 4ac plus 4bc plus 4c square. Okay, it would be 3a square. Now it would be 3a square plus 2b square. Now 3ab and minus 2ab, it would be plus of ab and 3ac. So plus 3ac. So 3a square plus 2b square, it would be 3ab minus 2ab plus ab, 3ac minus 2bc. Now if you open the bracket, it will be minus 4ac plus 4bc plus 4c square minus, it would be 3a square minus 2b square. Signs will be changes. Okay, sign would be changed because we are multiplying them by minus 1. So minus into this would be minus AB, this would be minus 3AC, and this minus and minus would become plus. So it would be 2BC plus 2BC. So after calculating the like and unlike terms, we have minus 3A square as it is, minus 2B square as it is, plus 4C square because they cannot be added or subtracted with any other term. Minus 4AC, let us find AB. So we do not have AB, so minus AB would be alone. Similarly AC. Plus 2BC and plus 4BC would be plus 6BC, right? So it would be plus 6BC. Okay, then AC minus 4AC and then we have minus 3AC, so minus 7AC. See, we have not left anything. Let us check. There are 8 terms and there are 6 terms. We have combined AC and AC and then we have combined BC and BC. So it would be minus 3A square minus 2B square plus 4C square minus AB plus 6BC and finally minus 7AC. So you should never be confused. You should always write them clearly and have some space within the terms so that you can actually write the powers correctly. Okay, let us move on to the next question. Now it is just simplification, so you can do that. It is not directing you to do anything. You have to do everything on your own based on the sign and operations. So it is 15a square minus 6a into a minus 2 plus a into 3 plus 7a, right? So it would be 15a square Now minus 6a into a would be minus 6a square, minus into minus plus, so it will be 12a. Similarly, a into 3 would be 3a, and a into 7a would be 7a square. So 15a square minus 6a square, it would be 9a square. 9 plus 7 would be 16. So 16a square, and then it would be 12a plus 3a, that is 15a. Okay, so it would be 16a square plus 15a. So that is the simplified version. Okay, let us move on to the next question. They are very simple questions, okay, just for practice purposes. Simplify this. Okay, so in these type of simplifications, always take care of the powers on the variables. Okay, if you put one power correct, the answer would not be right. So multiply them carefully. X square into 1 minus 3y square plus x into xy square minus 2x minus 3y into y minus 4x square y. Okay, so if you multiply them, it would be x square minus 3x square y square plus x square y square minus 2x square minus 3y square, then minus into minus would be plus, 3 into 4 would be 12 x square and y square. See how I have multiplied it. I am just calculating the powers. See, x square, then x, it does not have any x, so directly multiplied. Now x into x would be x square, y square would be there only. I am not seeing y actually, I am just focusing on the variable. I am matching x. Now x into x, x square, minus and plus, now you should be able to do it by now. Minus into plus would be negative only, minus 3 would be there, y into y, y square. Similarly, minus minus become plus, 3 into 4, 12. Since it was not having x, so x square will come as it is, but y into y would be y square. Now calculate it. X square minus 2x square, it would be minus x square, right? Minus 3 x square y square plus x square y square, so it would be minus 2 x square y square, and minus 2 plus 12 plus 10. Okay, so it would be minus x square plus 10x square y square, and now we have left this, so it would be minus 3y square. So that is the simplified version of the question. Let us move on to the last question. Now this is again a simplification. So I think that is the biggest simplification because it has 4 terms to be multiplied, and they will become 8 after multiplication. But we'll solve them using the like terms. Okay. So first of all, write it like this only. 4st into s minus t minus 6s square into t minus t square minus 3t square into 2s square minus s plus 2st into s minus t. So 4st, so it will be 4 s into s would be s square and t like this, minus 4s will be like this, t into t would be t square, minus 6 s square t, minus and minus would be plus, so 6 s square t square, minus 3 into 2 would be 6 t square s square, minus and minus would be plus, so it would be 3 t square s, right? Then plus and plus would be plus, so 2 s square t, and then it would be minus 2 s t square. Okay, let us cross check. It would be 4 s square t, 4 s square t minus 4 s t square minus 6 s square t plus 6 s square t square minus 3 square, okay, minus 3 3 into 2, that is 6 t square s square minus minus plus 3 s t square plus 2 s square t minus 2 s t square. Okay, so let us solve them. So 4 s square t, let us find s square t. See, 4 minus 6 s square t minus 2, do we have another term? Yes. So 2 s square t plus 4 s square t, 6 s square t minus 6 s square t, I think they will cancel out. Okay, so they will be like 4 s square t and minus 6 s square t minus 2 s square t plus 2 s square t, so they will become 0, so nothing we have to write. Now minus 4 st square, so let us see st square, yes, st square, so minus 4, this is also st square, so minus 2 st square plus 3 st square, it would be 1 st square, 1 st square minus 4 st square, it would be minus 3 st square, right? Now it is what, 6 s square t square minus 6 s square t square, so it would also be cancelled out. So this would be the final answer. So you can clearly see that this was so long of simplification, but the final answer was just a monomial. Okay, so that complete expression after simplification has become just a monomial. So this was all about this particular question. Now in this lecture we talked about how to multiply a monomial by binomial. We have also seen how to multiply a monomial with a trinomial in one of the questions using the same distributive property. Okay, so this was all about this lecture. I hope you understand my point. Thank you for watching this lecture till end. We'll meet in the next lecture. Till then, goodbye.